The universe is an incredibly vast and awe-inspiring expanse, filled with mysteries and wonders beyond human comprehension. While the Earth is a remarkable planet, teeming with life and a unique array of ecosystems, it is but a tiny speck in the grand cosmic scale. The vastness of space stretches beyond our wildest imagination, and our place in it seems minuscule in comparison. Yet, humanity's innate curiosity has always driven us to explore and understand the unknown, to reach out beyond our home planet and discover what lies out there in the cosmos. The advent of advanced technology, especially over the last century, has allowed humans to send spacecraft, rockets, and satellites into space, fueling a never-ending desire to uncover the secrets of the universe. This technological leap has sparked an insatiable curiosity to delve into the unknown, pushing the boundaries of our scientific knowledge. While we have made tremendous progress in understanding the universe's workings, much of what we know is still based on theories, hypotheses, and assumptions. Although scientists have developed reasonable explanations for many cosmic phenomena, much of our knowledge remains incomplete. This is where the Voyager 1 and Voyager 2 space probes come into play. These remarkable spacecraft have been instrumental in expanding our understanding of the universe and its distant reaches. Launched in the late 1970s, these probes have ventured far beyond the familiar realms of our solar system, traveling into the unknown and sending back invaluable real-time data. Their findings have enlightened us about the farthest corners of our solar system and even ventured into the unexplored territories of interstellar space. These are places that humans may not physically visit for generations, if at all, but the Voyagers are our eyes and ears in these distant regions. But as we uncover more about the cosmos, sometimes the data we receive carries unsettling implications. What happens when the information these probes send back contains disturbing warnings or revelations that challenge everything we thought we knew about the universe? What if the very fabric of our understanding is questioned? Join us as we take an in-depth look at the discoveries made by the Voyager missions, particularly Voyager 1, and the alarming messages it has conveyed about the future of space exploration and our place in the universe. For nearly half a century, the Voyager missions have led the charge in space exploration. These twin spacecraft have provided scientists with a treasure trove of data, offering insights into the mysteries of our solar system and the broader universe. The sheer duration of these missions is nothing short of remarkable, considering they were initially designed to last only 5 years. Yet, they continue to operate, far outliving their expected lifespans, and providing an enormous amount of data along the way. The history of the Voyager program is captivating in its own right. It began with the accidental discovery by a young NASA scientist, Michael Minovich, who realized that a spacecraft could use a planet's gravitational pull to slingshot itself further into space. This revolutionary concept allowed the spacecraft to travel much farther than previously thought possible, setting the stage for the launch of the Voyager missions. In 1977, Voyager 1 and Voyager 2 were launched, their primary mission to study the gas giants Jupiter and Saturn. These two planets had long been of great interest to scientists, with their immense size, complex atmospheres, and numerous moons. What the Voyagers accomplished, however, exceeded all expectations. Both spacecraft are equipped with 3.5-meter parabolic antennas that communicate with Earth, along with 16 thrusters to adjust their orientation and ensure their antennas remain pointed toward our planet. Their engines run on hydrazine fuel, and their onboard electronics are powered by thermoelectric generators, fueled by plutonium. In addition to these remarkable features, each probe carried 11 scientific instruments. These tools were designed to study the planets they encountered, from analyzing atmospheric conditions to examining magnetic fields. Over time, as the probes moved further from their original targets, some of these instruments were shut down, but many continue to function, sending back valuable data. One of the most ambitious parts of the Voyager missions was the so-called Grand Tour of the Outer Planets. This tour became one of the greatest achievements in the history of space exploration. Voyager 2, in particular, achieved the distinction of being the first spacecraft to closely observe Uranus in 1986 and Neptune in 1989. These encounters provided scientists with unprecedented views of these distant planets and their moons. Voyager 1, which had overtaken Voyager 2 just a few months after its launch, conducted flybys of Jupiter in 1979 and Saturn in 1980. These encounters made Voyager 1 the most distant man-made object from Earth, a title it still holds to this day. Despite the immense distances both probes have traveled, they continue to operate, with Voyager 2 currently functioning with 5 active instruments, while Voyager 1 has 4. Together, these probes are still gathering valuable information about the outermost regions of the solar system and the vastness of interstellar space beyond. As both spacecraft venture farther from the Sun's influence and into interstellar space, they continue to send back crucial data about the cosmic environment they encounter. This data is helping scientists piece together a better understanding of the space between stars, a region that had remained largely unexplored until now. But before we dive into the mysterious messages Voyager 1 has sent back, let's take a moment to appreciate the profound discoveries these two missions have made along the way. Imagine embarking on an epic voyage to explore the unknown regions of our solar system, with Voyager 1 and Voyager 2 as your companions. Their first mission was to take a detailed look at the majestic Jupiter and Saturn systems, and they succeeded beyond anyone's expectations. The images and data sent back by the Voyagers transformed our understanding of these gas giants. They revealed the intricate cloud patterns and turbulent weather systems of Jupiter, including its iconic Great Red Spot, a massive storm that has raged for centuries. The probes also provided new insights into Saturn's complex ring system, capturing stunningly detailed images that allowed scientists to study its composition and structure like never before. As Voyager 1 moved beyond Saturn and out of the solar system, Voyager 2 still had exciting targets ahead. In 1981, a carefully planned maneuver adjusted its course, setting it on a path toward Uranus. By 1986, long past its expected lifetime, Voyager 2 arrived at Uranus, where it made one of its most significant discoveries. The probe identified 10 previously unknown moons, expanding our knowledge of Uranus's satellite system. These moons had gone undetected by earlier telescopes, but Voyager 2's instruments captured their presence, adding them to the growing list of Uranus's known companions. Yet, the journey didn't end at Uranus. Voyager 2 pressed onward toward Neptune, its final planetary destination. In 1989, it sent back more than 9,000 images of Neptune and its moons, leading to the astonishing discovery of 9 new moons. Among these, Triton, Neptune's largest moon, revealed secrets that astounded scientists. Its diameter turned out to be different than previously thought, and it had surprisingly few craters for a moon of its size. More intriguingly, Voyager 2's data revealed that Triton's whitish-brown color was due to geysers spewing liquid nitrogen, which froze upon contact with the surface, creating a landscape of nitrogen snow. The Voyager missions left an indelible mark on our understanding of the solar system's outer planets. No other probe has since returned to Uranus or Neptune, and scientists continue to study the data collected during those historic flybys. The discoveries made by Voyager 2 at Uranus and Neptune have spurred ongoing interest in these icy giants, prompting further investigation by scientists around the world. Uranus, one of the lesser-known planets in our solar system, is classified as an ice giant, along with its neighbor Neptune. Despite the cold connotations of its name, much of Uranus is not frozen. Instead, the planet consists primarily of supercritical fluids, high-temperature, high-pressure substances that combine the properties of liquids and gases. Uranus is located about 1.8 billion kilometers from the Sun, making it the second most distant planet in the solar system. With a diameter over 4 times that of Earth, it is an immense planet. Yet, one of its most curious characteristics is its sideways rotation. Unlike most planets, which rotate in an upright position relative to their orbits, Uranus rotates on its side. Scientists speculate that a massive collision with a protoplanet in the distant past may have caused this unusual tilt. This event might also explain the presence of the 27 moons that orbit Uranus, possibly formed from the debris of the impact. Even more fascinating, about a decade ago, the Hubble Space Telescope detected a massive storm in Uranus's atmosphere, a gigantic white spot with winds reaching up to 143 km per hour. In addition to these violent weather systems, Uranus is home to frigid clouds composed of methane and ammonia, where temperatures can plummet to -197 degrees Celsius. While less prominent than Saturn's, Uranus also has a faint ring system, composed of dark, dispersed material. Neptune, discovered in 1846, holds the title of the most distant planet in our solar system. Located nearly 5 billion kilometers from the Sun, it exists in near-total isolation, far removed from the warmth and light of the inner solar system. To put its distance in perspective, the Earth is only 150 million kilometers from the Sun, while Neptune is more than 30 times that distance. Despite its remoteness, Neptune shares many similarities with its neighbor Uranus, including its size. With a diameter of roughly 50,000 kilometers, Neptune is comparable to Uranus in scale. However, it takes much longer to complete an orbit around the Sun, 165 years to be exact, while it spins on its axis rapidly, completing a full rotation in just 16 hours. When Voyager 2 visited Neptune in 1989, it observed extreme weather phenomena, including bright cloud bands and massive storms with winds reaching speeds of 2,100 km per hour, the fastest ever recorded in our solar system. Scientists believe that the low levels of solar energy reaching Neptune might allow these storms to reach such incredible velocities. However, these storms are not permanent, they may eventually dissipate or disappear. One of the most famous features Voyager 2 observed was the Great Dark Spot, a massive storm system similar to Jupiter's Great Red Spot. But when astronomers attempted to locate the Great Dark Spot a few years later, it had vanished without a trace. Some scientists theorize that internal heat from Neptune's core caused atmospheric turbulence that led to the storm's disappearance. Neptune's core remains one of the great mysteries of planetary science. Despite the planet's turbulent atmosphere, scientists estimate that its core is composed of rock and metal, with a mass between 1 and 1.5 times that of Earth. Temperatures within Neptune's core are thought to soar to nearly 13,000 degrees Fahrenheit, and pressures can reach several million bars. Both Uranus and Neptune also have highly unusual magnetic fields, which have long puzzled scientists. Unlike Earth, where the magnetic field is closely aligned with the planet's rotational axis, the magnetic fields of Uranus and Neptune are significantly tilted, adding to the mystery surrounding these distant giants. Now, as the Voyager missions push further into interstellar space, they continue to send back data that challenges our understanding of the universe. Voyager 1 has crossed into the region beyond the Sun's influence, where it has encountered surprising phenomena, including the detection of strange, unexplained signals. These signals, combined with data from Voyager 2, raise important questions about the nature of interstellar space and the future of space exploration. As we analyze the disturbing messages sent back by the Voyager probes, we are reminded that the universe is far more complex and mysterious than we once believed. Let me know what you think in the comments section. If you enjoyed this deep dive into the Voyager missions and the incredible discoveries they've made, be sure to like the video and subscribe for more space exploration content.